All right, so in our second trigonometry lesson, we're going to look at the types and properties of triangles. So our objectives today are to identify equilateral and right angle triangles and to identify obtuse, acute, and right angles. So we're going to look at right angles. We're going to look at the types of angles first, and then we'll do the types of triangles. So what are the types of angles? So first of all, we have right angles, and a right angle is an angle which measures 90 degrees. So it looks like the angle that you'll see just, I guess I'm going outside of my zone that I'm allowed to point at, right up here in the corner. Okay, so that's our right angle. It's exactly 90 degrees. The legs of the angle, so leg 1 and leg 2, are perpendicular to each other. Acute angles are angles that measure less than 90 degrees. Okay, so anything under 90 is going to be acute. And obtuse angles are angles which measure greater than 90 degrees but less than 180. Now, you are expected to know these terms, but I do like to give some tricks for helping you remember. So think about wordplay. Obese is something that's large or someone that's large. I don't exactly love hearing that word at the doctor's office. Okay, but it can be obese and obtuse. They're both the large angle. The acute angle is the small one. Children are much cuter when they're small than when they're big. We could probably argue that with some people, but generally speaking, behaviors are cuter when things are small than when they're large. So you can use, oops, I bumped my mouse here. So you can use some of that wordplay to help you remember which is which. Okay, so acute is less than 90, obtuse is greater than 90, but smaller than 180. I don't have the angle for when we're greater than 180. We actually called it a reflex angle, and we'll add a couple more angles in once we get past our trig functions. But for now, I'm just giving you some of the basic language that you're going to see in this particular section. Now, there are 6 types of triangles. We have acute triangles, equilateral, obtuse, right angle, isosceles, and we have scalene, okay? So you're going to find there are 6 different types of triangles. Move my head here a little bit. And we're going to look at what properties define each of them, and then we'll do a little bit of a challenge to see, can we identify properties of a triangle, knowing each of these wordings and what they mean. So first of all, a right angle triangle has one angle that measures 90 degrees. And one of the ways that we are able to mark a 90-degree triangle is we put this little square here in the corner. And that little square in the corner means that you have a 90-degree angle. So I no longer have to write 90 degrees. So long as I put that in, that shows us that your angle is 90. Okay, so that's what that means. An acute triangle just has all angles acute, so all angles in this triangle are less than 90 degrees. If you have an obtuse triangle, it just means that you have one angle, lost the letter here, one angle which measures greater than 90 but less than 180. So you'll see there's one angle here that happens to be larger. One angle here that happens to be larger than 90 degrees. Okay, you can only in a triangle, just one of those pieces, you can only have one angle larger than 90 degrees. You will never have two. It's impossible. The reason why it's impossible is this very, very, very important piece of information. In a triangle, all of the angles will sum to 180 degrees. Every single time, all of the time. So anytime you're dealing with a triangle, all the angles in a triangle sum to 180. I guess I didn't have to edit that wording. It's a matter of how I was interpreting it. We'll just take that. All angles of all triangles sum to 180 degrees. Sometimes what I think I wrote, I read backwards. All right, so that's a really important concept. We're going to use that multiple times throughout this lesson. You'll use it multiple times as well as you go through the practice. Then we have 3 other types of triangles, and these are triangles that are categorized by their sides. So an equilateral triangle is a triangle that has all sides the same length. Since all sides are the same length, it also means that all angles are the same measure. You'll find out what that measure is later. I'm going to give you a calculation to do. In an isosceles triangle, you have two sides that are equal in length, and these two little lines, we use two little lines on each side, and that's just a way of us showing that they're the same length, which means it also has two angles which are the same size, and the angles that are the same size are right here. It's between the sides that are the same length, side that is the same length, and the one that's different. Okay, so these two angles will be equal in measure. A scalene triangle is the one that gives us the least information, although it may be the most common triangle. And in a scalene triangle, no angles are the same size and no sides are the same length. Okay, so nothing's the same. Okay, so no sides are the same, no angles are the same, everything's different in a scalene triangle. Now you will find that some triangles, you could have an obtuse triangle that's an isosceles. I would guess, I haven't measured, I don't know, I didn't check to see if this is a 90 or not, but this triangle could very easily be an obtuse triangle. You could have an isosceles triangle that is acute. An equilateral triangle we're going to find is acute. And a scalene triangle could be obtuse or acute, it wouldn't matter. We will find that right angles can actually fit into either isosceles or scalene categories. So there's multiple names we can give to triangles. And sometimes by combining their properties in word problems, it gets us thinking through some really good challenges to be able to identify what are the properties and how can we use those properties to help us solve the triangle. All right, so we're going to do some application of definitions. It's really hard to do practice questions for definitions. I think I can get myself situated here so that this actually works. I'm not sure. We'll see, and I'll read the question out to you. I think I'm blocking a corner of a word over underneath of my head. It takes a little bit to figure out how to best sit to make this all work. All right, so the very first question says, angles in all equilateral triangles measure the same. What is the angle? So it doesn't matter what equilateral triangle that you have, all of them will have the same size. So we learned before that all angles in a triangle add to 180 degrees. So what we do is we start with 180 degrees. There are three angles in a triangle, so we're going to divide by 3 and we get 60. So if you have an equilateral triangle with all sides equal, every angle is 60 degrees. That's a property that you can memorize. It will always be true. The second question says, can an obtuse triangle be an isosceles triangle with two angles measuring 15 degrees, 18 minutes, and 3 seconds each? If yes, what's the measure of the obtuse angle? So for it to be an obtuse angle, that means one of the angles needs to be bigger than 90 degrees, but less than 180. So what I'd like to think of this one is I think, okay, I've got a picture. Could this be true? So these two would be the same, and this one, these angles would be the same, and this would be 15 degrees, 18 minutes, 3 seconds. So let's think, how much have we used up if we have two of those? So I'm going to say, okay, I've got two angles that are 15, 18, 3, 15, 18, 3. Add them together. So I get 6 seconds. 18 and 18 is 36. And 15 and 15 is 30. Now I take 180 degrees. Ooh, I can't just subtract degrees, minutes, and seconds, so let's switch it. This 180 degrees is equal to 179 degrees, 59 seconds and 59 minutes and 60 seconds. Then we're going to subtract 30, 36, and 6. And we're going to find out, well, what do we have left? So 60 minus 6, I didn't even pull my notes out for this one. 60 take away 6 is going to leave us with 54. 59 minus 36 leaves me with 23. And 79 take away 30 leaves us with 149 degrees. So the leftover angle, this one up here, so that's going to be our big one. This would be 149 degrees, 23 seconds, and minutes and 54 seconds. So yes, it's obtuse, and yes, we can have both of the small angles have those measurements. So an obtuse triangle can be an isosceles triangle with two angles measuring 15 degrees, 18 seconds. So there's our yes, and this is our proof. Okay, so that's one of those things that I oftentimes will get you to do a question. I won't ask you just say yes or no. It'll be give me proof. So I want you to actually think about it. And I can see my head just blocked everything that I just wrote. I'll figure that out for you for later, and let me know if you need some more of that. I'll post the slides with the ink as well, so that you can kind of look through if since my head was in the way. I'm figuring out how these views work in Teams, and I haven't quite figured out how to adjust on the fly. Sometimes will give me an extra screen for changing things, and then sometimes it doesn't, so bear with me. All right, the very last question. One angle of a triangle measures 148 degrees. Another angle measures 16 degrees. What possible names could be given to this triangle? So first of all, we need to figure out what are all the angles. So we know this is 148. We know we have a 16 here. What's this one going to be? All right, so we're going to take 180. We're going to minus the angles that we know, or subtract the angles that we know. So minus 148 minus 16. So take a moment in your calculator, take 180 minus 48 minus 16. Now, for the most part, if you actually follow along and pull your calculator out, it's really worth doing it. You may find you happen to catch one of my errors. Great, let me know. It happens. Okay? All right, so for this one, 180 minus 48 minus 16 left me with 16. So this leftover angle happens to be 16 degrees. So I have an obtuse angle, so that means this is an obtuse triangle. So that's one name we can give it. But it has two angles that are the same, so it must also be isosceles. And this is where I have this list over here to help me spell them. There are some words that I have a very hard time getting letters in the right order with. All the right letters there, but just not necessarily the right order. So those are just kind of using words in order to solve and look at the properties and match the definitions up. I have a couple other questions that are just, what are the angles? So this is getting us to practice that getting us to practice using our 180 degrees for our sum of angles in a triangle. So I want you to think about, identify the possible names you could give these triangles. I want you to think about their properties, but I also want to know what's the missing angle in each of them. So for this, we'll start with number 1. So this one, whenever you see the square in the corner, that means we have 90 degrees. So that tells us right away that this is a right triangle. Okay, I'm going to abbreviate just for the sake of space. So it's a right triangle. And our extra angle. So to figure it out, we do 180 minus 90 minus 30 gives us 60 degrees. A 30-60 right triangle is a very common triangle. If you were to get a protractor set from like one of those math sets that has the triangles, it will often give you 30-60 triangles, and you can rearrange those in many ways to get some of the most common angles used. All right, so we have a right triangle. All of the angles are different, which means all the sides will be different as well. So we could also say that this is a scalene triangle. So just another name for it. The one I want you to really remember is that it's a right triangle. The term scalene I'm not as concerned about. Knowing it's a right triangle is important. If we move over to the next one, so if we move over here, again, we have our little box in the corner. So this means it's right. Okay, we just need to find out what's the missing angle. So 180 minus 90 minus 50 leaves us with 40 degrees. Okay, so this one, because all the angles are different, it is also a scalene triangle. Okay, now we move down to the bottom here. We have two angles that are the same. So as soon as you see two angles that are the same, we also know two sides will be the same length. This one is an isosceles. See if I can spell it. I-S-O-S-C-E-L-E-S. There's just too many S's in there. Too many S's and too many E's. All right, in terms of the size of the angle, so to get the angle here, 180 minus 40 minus 40. So this angle is 100 degrees. So because it's greater than 90 but less than 180, it is also obtuse. Because we have an obtuse angle, that angle that's larger than 90 degrees. Going over to number 4. Note, first thing, we have the box in the corner, which tells us we have a right triangle. So that's really important for us to work with. Now, to figure out the missing angle, we have 180 minus 90 minus 20. That leaves me with this corner equal to 70 degrees. So it's right, none of the angles are the same, so it's also a scalene. If the angles are different, the sides will be different. It's just one of the rules. Okay? So very simple, not complicated. These ones are probably less complicated than when you have words. I have 4 other ones, and we'll see if we can get them solved as well. So 5, we have an isosceles triangle with one angle that's 30 degrees. We probably should have written this a little differently, but that's okay. I like denoting angles that are different sizes. It's good to use 2 different symbols to show that they're different sizes. So to figure out the missing angle, I take 180 and I subtract 30. So that leaves me with 50 degrees, 150 degrees to split between 2, and we're going to divide it by 2, which gives me 75. So this angle is 75 degrees and 75 degrees. That means this side and this side will both be the same length. All right, so 2 sides the same, 2 angles the same. So it's isosceles. Note the size of all the angles. All of the angles are less than 90 degrees. So we can also say it's an acute triangle. All right, this one we have an equilateral triangle. We've already done it. We've already done this one. So equilateral triangle, we have 180 degrees divided by 3 corners. Leaves us with 60 degrees each. If they're each 60 degrees, it's equilateral and it is also acute because they're less than 90. Biggest things is remembering those term definitions. I know I keep kind of going back to some of those simple things, and I realize they're simple, but I also know that if you don't use them, if we don't repeat them, you won't remember them. That's just kind of the way it goes. And then 7, we look at 7 here. Got 2 different screens on the go on my computer, which is a little tricky to see. So here we have our 90 degrees. So this means we have a right triangle. Okay, so with 90, and then we want to find out what's the missing. So 180 minus 90 minus 52, and that should leave us with, leaves us with 38 degrees. Okay, you could also label it a scalene if you wanted to. I won't take the time to write it in. And for the very last one, I'm going to just kind of duck out of the way here. We have an isosceles triangle. And for this one, you'll see it's got this angle and this angle are the same. And down in the corner, it tells us that we have 90 degrees. So we want to split what's left over between the other two. So we have 180 minus 90 leaves me with 90. 90 divided by 2 gives me 45. And that gives you all of your angles. So quite straightforward, not complicated to figure out. I think you should be fine to go through these. It's kind of nice when the first 2 lessons that we have to do online are a little easier concepts for us. So quick lesson recap, there are 3 common types of angles. So you have acute angles that are less than 90, obtuse angles which are greater than 90, also less than 180, I didn't throw that in there. You have a right angle, which is exactly 90 degrees. The angles of a triangle will always sum to 180. Right angle triangles always have a right angle. Isosceles triangle, 2 sides equal, 2 angles equal. And an equilateral triangle will always have all sides and all angles equal. So those are the main highlights that I want you to use as you go through your worksheet